Right. So now we have seen what are acidic radicals, what are the different categories of acidic radicals. So let us go with the first category or first class of acidic radicals, that is, group 1 acidic radicals which respond to dilute sulfuric acid or dilute HCl. So what are you going to observe? Let's see. So the first anion which I picked up is carbonate radical. Now, as soon as I told you, when you get the test tube, when you take the test tube, when you add dilute sulfuric acid into this, or if you add dilute HCl and you add salt into this, right? So the particular salt dissolves and it starts giving effervescence or evolution of gases. Okay, done. So this, suppose if this is acidic radical group 1, they start giving us, what is that word called? Effervescence or evolution of gas. You will observe evolution of gas coming, means there's gas which evolves out of the test tube. Effervescence or evolution of gas. Let us see what it is. Done. Here the first test, what I did is I wrote the gas which evolves, what is a radical, what is a confirmatory test. Why did I write like this? Because your examiner asks you like this only. What is a gas evolved when if you detect the presence of carbonate anion? You have to say carbon dioxide is a gas evolved. So that's the reason I've written. Let us discuss now. So I've taken the gas, I've taken the salt, I've added dilute sulfuric acid, dilute HCl. I started observing effervescence. Suppose if the effervescence is colorless and odorless, if you're finding that effervescence of gas which is coming off the test tube is colorless, odorless, then first important point you have to note it is carbon dioxide gas. So carbon dioxide gas, what is the characteristic? It is colorless as well as odorless, right? So why this carbon dioxide gas is released? What are the reactions? Let's see. So first of all, you're going to take the salt. So as I told you, take the salt. Now, sorry, whichever salt, it can be sodium carbonate, it can be zinc carbonate, barium carbonate. Different schools will give different combinations of carbonates. So here I've taken sodium carbonate salt. Now I've added with sulfuric acid, I added dilute sulfuric acid to this. So when I added dilute sulfuric acid, this part, immediately it forms sodium sulfate, water and carbon dioxide gas has started evolving out. That is where that carbon dioxide is written here. So that effervescence is due to carbon dioxide, colorless, odorless gas. I'm going to take this colorless or carbon dioxide, that particular test tube. Basically, we use a delivery tube. What we do is we take the test tube like this and we fix one delivery tube and take one more test tube which has lime water. So this is carbon dioxide delivery tube we call. So when you are passing that whole thing, that carbon dioxide gas using delivery tube into the lime water. So calcium hydroxide is what? It is lime water. So when you take this, immediately carbon dioxide, it combines with lime water forming calcium carbonate, and what is left out? Water. This calcium carbonate, which color is that? This is milky white PPT. Milky white PPT. This is where is the confirmatory test for your carbon dioxide. Once again, the carbon dioxide which is released here, if it is sent through the test tube, through the delivery tube into lime water like this, immediately the lime water turns milky white. Why? Because of the presence of formation of calcium carbonate in the test tube. So this is your question, Viva question. What did she ask? What is the color of the gas which is evolved when carbonate is formed? Carbon dioxide. Second question, what is this PPT? What is the name of the PPT formed when carbon dioxide is sent through lime water? Why does lime water turn milky? Your examiner will ask you. You have to answer. Lime water turns milky due to the formation of calcium carbonate that in the test tube. Done. Further, what you can do is take this calcium carbonate. Further, you add water. I mean, not water, already calcium carbonate water is there. You take calcium carbonate, that same test tube which has water, and try to pass more of carbon dioxide into that. Okay, now more of carbon dioxide I'll be passing into a test tube, means this has got converted. So I'll be passing into the test tube containing calcium carbonate plus water more. Then what will happen? This calcium carbonate, further it starts dissolving. The milky white PPT starts dissolving, and it will dissolve completely, and you get a soluble product, means the whole white PPT dissolves and it becomes clear solution, and that clear solution is due to the formation of calcium bicarbonate. calcium bicarbonate. So let us recollect once again, don't get confused, simple. First, what should you do? You have to take test for acidic radicals. After you get a colorless, odorless effervescence when you add dilute sulfuric acid or dilute HCl, you have to perform this test. What is that test? Take that salt, what is given to you, add sulfuric acid, immediately you get the formation of sodium sulfate, water and carbon dioxide. Now this carbon dioxide is a colorless, odorless gas. Take that carbon dioxide with the help of a delivery tube, or allow it to enter into a test tube containing lime water, calcium hydroxide lime water. This carbon dioxide combines with lime water, turning lime water milky. So the examiner asks you, why is the lime water turning milky? You should say, because of the formation of calcium carbonate. That calcium carbonate plus water. Now you take this test tube containing calcium carbonate plus water, and what you do, you further introduce carbon dioxide. Further introduce carbon dioxide. This white PPT, whatever is there, it will become soluble. It will dissolve. Why? Because of the formation of calcium bicarbonate, which is a soluble product. So this particular test confirms the presence of carbonate ion. So note it, keep it on this one, keep that confirmatory test in the test tube rack only. Don't discard that. Never remember, confirmatory test you should never discard. Your examiner will call you, okay child, show me your confirmatory test and explain what it is. Done. So now calcium carbonate, this is the test, these two are the confirmatory tests of carbonate. So let us come back and do the next type of anion, group 1 acidic radical, that is acetate anion. How to test it, what is the gas, what is the confirmatory test also. Right. After carbonate anion, let us come back and just analyze how to identify acetate anion. Done. As I've told you, I've divided the board into 3 equal halves. That is, first would be the gas evolved. Why did I write this? They'll ask you what is the gas evolved when you test for acetate anion. So that's why I've written. So basically, when you're testing for acidic radical, the gas evolved, or which you observe when you add dilute sulfuric acid or dilute HCl, is colorless gas with the smell of vinegar. This is a characteristic test for acetate anion. So you will be observing colorless gas, but when you smell it, you will get the strong smell of vinegar. So if you get the strong smell of vinegar, that is acetate or acetic acid fumes which have come out. That means that contains acetate anion. Let us come back and see the reactions. Now let us assume the salt which is given to me is sodium acetate. It can be lead acetate, sodium acetate, zinc acetate. Means different schools, again they give different combinations. Now we are basically testing acetate. So when I am given acetate, sodium acetate, as I said, I'll be doing or adding dilute sulfuric acid. Why dilute sulfuric acid? Because this is group 1 acidic radicals. So when I add dilute sulfuric acid to this, immediately, as you have seen, sodium sulfate comes out, and the leftover acetic acid is there in the test tube. So this acetic acid comes out in the form of colorless gas with the smell of vinegar. Now I have to do the confirmatory test, because as I got an idea, I have smelled it, I got that it may be acetic acid or acetate anion. Now I'll start doing the confirmatory test. There are 2 confirmatory tests which you can easily do and get the confirmation for acetate anion. What are they? First one, you're going to take your salt, add FeCl3 solution to that. What is the color of that? Because the FeCl3 it has a different color. Reflected light is one color, and the complementary, that is also absorbed complementary color will be a different one. But basically FeCl3, we take it as an yellow color solution, or yellow color powder, crystalline powder. So when you add in the form of a solution, right, so that particular yellow color solution, it immediately turns, or it forms a complex with which one? Sodium acetate. See here, this NaCl comes out, and the leftover CH3COO3 are there, isn't it? It forms a complex with this. What is the name of this complex? The name of this complex is called, we call it as iron 3 acetate. Okay, iron 3 acetate. See here, 3. What is the color of this? From yellow, now the solution will turn into blood red color. So the color of this is blood red. So blood red color, iron 3 acetate is formed. And as I said, NaCl is released, or NaCl is there in the test tube. Now what we are going to do, we are means this change from yellow to red confirms the presence of acetate anion in the given salt, because it has formed a complex with this yellow to red. Next confirmatory test which we do is, again I take the salt. Now I'm going to this time add what acid? Oxalic acid. This is what? Oxalic acid. No, once again, let us see this. Sodium oxalate. Yeah, oxalic acid I add to this. So this oxalic acid, when I add, what will happen is the sodium, means there is a cleavage of the bond here. This sodium forms a bond with this, and what is left out? This hydrogen comes out as acetic acid. So sodium oxalate is formed here. But what is important here is, as I take salt, I add oxalic acid into that. It immediately forms complex, means it forms sodium oxalate, and apart from that, you get an evolution or a smell of vinegar. A colorless gas evolves out. That colorless gas is acetic acid. That has a smell of vinegar. Hope you understand, students. So remember, the first confirmatory test is with FeCl3 turning yellow to red, blood red. The next test is for combination with oxalic acid, which evolves or releases a colorless gas which has a smell of vinegar. So if you find the smell of vinegar and if it turns yellow to red, you can confirm that it is, or the particular salt has an acidic radical which belongs to group 1, that is acetate anion. Right. Now we have already seen the identification of the carbonate anion. We have also seen the identification of acetate anion along with the confirmatory test. Now let's come back. Suppose if the particular test tube, as I told you, if it shows an effervescence or evolution of gas with dilute sulfuric acid or dilute HCl, we can analyze. It may be carbonate, it may be acetate, it may be sulphide also, sulphite also. Now let us come back and see for sulphide. So suppose if the test tube or if the particular salt contains a sulphide anion, the gas which is evolved is hydrogen sulphide gas. So remember, hydrogen sulphide gas is a colorless gas with the characteristic rotten egg smell. Okay, let us see the reactions. So now what did I do? I have taken the salt. As soon as I entered in the lab, I have taken the salt which is given to me. Now I am testing with which acid? With dilute sulfuric acid. So I am taking the test tube, I am adding the salt, pinch of salt, adding dilute sulfuric acid and observing it. So immediately when you take the salt and dilute sulfuric acid, suppose if sulphide is present, it forms sodium sulphate, and from the test tube, your colorless gas with the odor of a rotten egg smell, that is hydrogen sulphide gas, starts coming out of the test tube. You smell it. If you get the smell of vinegar, it is acetate. If you get the smell of rotten egg smell, that is sulphite. But once you get the hydrogen sulphide or the colorless gas with rotten egg smell, immediately you can start with the confirmatory test. Here, suppose if the salt is zinc sulphide, just like this, sodium forms sodium sulphate, zinc forms zinc sulphate. But what is common? Hydrogen sulphide gas evolution is common. So I'll be doing the confirmatory test now. So basically there are two confirmatory tests which you can easily remember. So the first confirmatory test, now I know it is hydrogen sulphide. Now I'll take lead acetate from the rack and I'll add to this. What will I get? When you add lead acetate, immediately lead, whatever is there, it comes out. See here, acetic acid comes out. Means it forms in the test tube, and the whole it will be present in the test tube, and the whole black PPT of lead sulphide is formed. Lead sulphide is black PPT, so that black PPT is formed. As soon as you see black precipitate forming in the test tube, 100% confirmed it is it is your sulphide anion. Once again, let us recollect. I have taken the test tube, I have taken the salt, I have added dilute sulfuric acid. I saw the observation, or have seen the evolution of colorless and a gas which has rotten egg smell. I have taken that. I started with the first confirmatory test, adding lead acetate. When you add lead acetate, immediately you will get a black PPT of lead sulphide in the test tube. When you get a black PPT, 100% confirmed it is sulphide anion. Now one more confirmatory test is, take your salt and add this. What is this? Sodium nitroprusside. Very apt, very perfect test you will get. Sodium nitroprusside is, which is a, what is the color? The sodium nitroprusside, it is a crystalline orange color salt. You take that sodium nitroprusside and when you add to your salt, immediately what will happen? Because it has dissolved in dilute sulfuric acid, that solution is there. You add to this, immediately you will get a formation of the orange color crystals, whatever are there. The whole thing will get converted into a violet color complex. Once again, salt plus sodium nitroprusside, salt solution in sodium nitroprusside, from orange color it will turn into a yellow, turn into a violet color complex. From orange it will turn into a violet color complex. Here it has turned into black color complex, black color precipitate. Here it has changed into violet color solution. What is the name of this complex which has formed? IUPAC name, let's see. See here, sodium pentacyano nitrosyl thiol ferrate complex. Okay, done. Let us write the violet color. What is, if the Viva question, if the examiner asks, what is the name or UPSC name of the violet color complex formed when you add your nitroprusside, sodium nitroprusside to your salt given? So what should you say? Name of that, I am writing the name here. It is sodium, IUPAC name, sodium pentacyano. What is that? After that, after pentacyano, nitrosyl. Next is S, thiol. Next is ferrate 6, ferrate 6 complex. This is your IUPAC name. What is the color of this? This is violet in color. So this is the confirmatory test. So remember, once you get rotten egg smell, confirm it is the sulphide anion which is present in the salt. Now let's come back and do the next question, that is your next class of acidic radical. Right. Now we have already seen the identification, means what is the procedure of identifying carbonate anion. We have seen how to identify an acetate anion. We have seen the identification of sulphide, that is S-2, that is from hydrogen sulfide gas. Now we'll be seeing how to identify sulphite anion in the given salt. So basically, whenever sulphite is given to you, ITE -2, remember, if it is sulphate, it is SO4. So if sulphite anion is present in the given salt, remember, the gas which evolved is sulfur dioxide. Don't get confused. Once again, if it is sulphide S-2 anion present, the gas evolved is H2S. Let us write that. If S-2 anion is present, the gas evolved is hydrogen sulfide. If SO3-2 is present, the gas evolved is sulfur dioxide. Both will have that will have means burning rotten egg smell, this particular thing. Here it will have burning sulfur, means very suffocating strong smell of sulfur will be there. Don't get confused. Your teacher may ask, what is the gas evolved here, what is the gas evolved here. Done. So whenever there is sulphite, there is evolution of colorless gas with suffocating odor, having a smell of sulfur when you add sulfuric acid. Let us come back and see what I am trying to explain. Now my teacher has given me sodium sulphite salt, sulphite. I am going to take that salt in a test tube and add dilute sulfuric acid to this. What will happen? Sodium sulphide gets converted to sodium sulphate, water and sulfur dioxide gas. See here, this sulfur dioxide gas evolves. What is the color of that? It is colorless gas with suffocating and burning smell of sulfur. Now once I observe that burning smell of sulfur, then I'll start doing the confirmatory test for this. Now what am I going to do? I am going to take the sulfur dioxide and bubble it. We call it as bubbling. We bubble it through acidified potassium dichromate solution. What is the color of acidified potassium dichromate? This acidified potassium dichromate is orange solution. When I bubble it, what will happen? Remember one important reaction. This is very important reaction. Here potassium dichromate is an oxidizing agent. Sulfur dioxide is a reducing agent in this case. So when you bubble sulfur dioxide to acidified potassium dichromate, immediately whatever Cr2 minus 7, what is the charge on this? This is Cr2O7 minus 2. The Cr2O7 minus 2 gets reduced to Cr plus 3. See here the charge is Cr plus 3. So when during this process, Cr2 minus 2O7, which is an oxidizing agent, which will get reduced to Cr plus 3. During this process, the orange color solution, whatever is there, gets converted into green color solution. Immediately orange turns into green. So when orange color potassium dichromate turns into green, it is confirmed there is sulfur dioxide gas present in that. Means sulphite anion is confirmed. Okay, right. So this is an oxidizing agent, this is a reducing agent. From Cr2O7 this gets reduced during formation of green color. Let's come back and see one more confirmatory test. So I'm going to again take the salt. Now I understood when orange is turning into green that sulphite anion is present. I'll go to the next confirmatory test, that is take the salt and add barium chloride solution to this. When you add, as we know, first barium sulphite and sodium chloride is formed. You get a white PPT in the test tube. Now you take the same white PPT and add HCl to that. When you add HCl to that, immediately the white PPT dissolves and it becomes soluble and you get a clear solution of barium chloride. So completely white PPT dissolves out in the HCl and you get a barium chloride soluble solution, clear solution. So with the evolution of sulfur dioxide gas. So once the sulfur dioxide gas evolves, confirmed that SO3 minus 2 is present. So hope it is clear, students. Once again come back, take the salt, add dilute sulfuric acid and observe the formation of sulfur dioxide gas which has burning sulfur smell. Bubble it into acidified potassium dichromate. Acidified potassium dichromate means which has acid as well as potassium dichromate. Immediately orange color solution turns into green. Now go with the next confirmatory test. Take the salt, add barium chloride to this. As we know, first you get a white PPT of barium sulphite. Further, when you add HCl to this, dilute HCl to this, immediately you'll find that the particular white PPT dissolves, it becomes soluble due to the formation of barium chloride. And there is evolution of sulfur dioxide gas from the test tube. So such test will confirm the presence of sulphite anion in the given salt.